Thank you very much. Okay, so as I alluded to, we're going to talk about how you look after the statistics for the database. And statistics for your cost-based optimizer are absolutely critical to delivering performance to the system. If you don't get the statistics right, your performance is going to become problematic. I'm an independent consultant once again these days, and I specialize mostly with helping people with performance issues. And I've always said I'll do PeopleSoft on anything and anything on Oracle. There's the URL for the website, and there's a couple of blogs. There's a very much PeopleSoft orientated blog, and there's a more Oracle generic blog. To my Oracle friends, I'm the PeopleSoft guy, and to my PeopleSoft friends, I'm the Oracle guy. So I sort of sit on the dividing line, that gray fuzzy area between the database and the PeopleSoft application. I'm also an ACE director, which just means that I like writing and talking about Oracle related subjects. And maybe one or two of you have seen the book. And there are things that as a PeopleSoft administrator or developer, you need to do in an Oracle specific way. And there are things you need to get your Oracle DBA to do in the context of PeopleSoft. And there are some things you need to stop them doing, because otherwise PeopleSoft will either break it or they'll break PeopleSoft. And because I can see both sides of the coin, I can sort of stand between the PeopleSoft teams and the Oracle teams and sort of translate from one to the other. And that's what gave rise to this particular presentation, because it talks about how you actually manage the statistics thing in Oracle for a PeopleSoft system without really upsetting the DBA and making his life hell, and delivering performance to PeopleSoft. And really one of the goals is that at the end of this, you should be able to say, well, look, my PeopleSoft Oracle database, I'm going to manage it the same as I manage every other Oracle database in my estate. Just because it's running PeopleSoft doesn't mean I don't do the standard Oracle things that an Oracle DBA expects to do on every one of his databases, whether they're running PeopleSoft or whether they're running something else. That's got to be the goal. You don't entirely achieve it, but that's where we're going. We're going to talk about database internals, how the optimizer works. What is an optimizer? What do we mean by cost and statistics? And what are these statistics things anyway? And then we'll talk about one or two of the things that you do during runtime to manage them. I saw in the chat earlier, someone referenced PSCBO STATS, and I will discuss that and give you my opinion of that. And I will perhaps talk about an alternative to that. And some other things at the end, not really statistics related, but closely related, dealing with how you get things to perform well, which is mostly about delivering the right statistics, but sometimes isn't. Sometimes it's more than that. What happens when you submit a SQL statement to a database? The database has to determine how it is going to execute that SQL statement. And this is a diagram. I had to go all the way back to the Oracle 9 documentation for this. This is roughly speaking what happens when you pass a SQL statement to the database. First, it passes it to make sure it's syntactically correct. There was a thing called the rule-based optimizer. It's actually still there, and Oracle use it themselves for some of their own internal code. And basically, it's a different mode of the same thing, the optimizer. It used to be that there were 14 hard-coded rules based upon static analysis of the SQL statement that determined how you executed a query. That was replaced in Oracle 7 with the cost-based optimizer. And now you have volumetric statistics, how many rows, how many blocks are in a table or an index, how many distinct keys, what's the range of value on my column. And these volumetric statistics are fed into a mathematical model, and that mathematical model is the cost-based optimizer. And what it does is it costs all sorts of possible execution plans and picks the cheapest one. And it does that for every SQL statement that you give it. Now, of course, it's got a lot more complicated in the 20 odd years since that was introduced. There is a whole arc of development that Oracle have put in. It's a never ending story, and the optimizer has got more clever, and it does additional transformations, and there are other forms of optimization to save it work. But essentially that's what it does. And all databases, all relational databases have an optimizer of some sort. SQL Server, DB2, all of the SQL databases, you have to give it a SQL statement and it has to decide how to execute it. Which table do I start with? What's the next table? How do I join between tables? How do I look at which index do I use on a table? That's the job of the optimizer. Rule-based optimizer, desupported many releases ago. So the only thing that we use now, of course, is the cost-based optimizer. And what it's doing, it's not that different to the GPS in your car. It's calculating the cheapest route. Your GPS in your car calculates all possible routes and chooses the least expensive, and it prunes down a route. So as soon as you get to the same point and you've got there cheaper by a different route, that route is then planned out, is pruned out. And the same thing happens in the optimizer. In your car, you cost a journey perhaps by distance or time, or you might use a blended measure. You might factor in fuel cost. If you've got tolls, you might factor in the cost of the tolls. Some route planning software factors in congestion. I'm passing through this area which gets at this time of day when it gets congested. And so you have this blended measure of cost. And again, the optimizer is no different. It's trying to say, how long will the SQL statement take to execute? The optimizer cost is supposed to be proportional to the execution time. You could say that the cost is actually time, where the unit of time is the duration of a single block physical I/O. That's never been entirely true, and it's less true today than it used to, but it's very roughly what cost is. And they factor in CPU cost, and there's a whole load of built-in rules, heuristics, guesses effectively, to say, well, I'm going to make this assumption here and that assumption there. And what comes out is for every possible execution plan is a cost, and it picks the cheapest execution plan that it can find. And that calculation is fed by these statistics, which you collect by collecting statistics, either by running the DBMS stats gather table stats command, or by allowing Oracle itself to run the maintenance window job that by default runs overnight. Which brings us to what is sometimes known amongst Oracle folk as the ENSOR paradox. So this is Dave ENSOR. Dave has long since retired from the Oracle world. He worked inside Oracle. He was responsible for BStat, EStat, and he worked with Graham Wood. And that team then produced AWR, and then Graham Wood went on to be the lead architect on active session history. And even Jonathan Lewis has called him the grand old man of performance optimization. I was very lucky to be able to go and see Dave present at UK Oracle conferences. Dave is credited with this statement. The only time when it is safe to gather statistics is when doing so would make no difference. What happens when you gather statistics? Well, the plan might change, or it might not. But what happens if you don't gather statistics? Well, the plan might still change. It might change because the data has changed, or the bind variable values in your code or your literal values change because your data has changed. And if the statistics haven't changed, that changes the calculation of cardinality, how many rows I'm dealing with at different points. And that can result in a change of execution plan. The usual reason is that those literal or bind variable values, they've moved outside the region of the range of column statistics, or they've moved into a region where the data is skewed differently because it's not uniformly distributed. So when you ask why do we spend so much time and effort gathering optimizer stats, most of the time it's because we want the plans to remain the same. I've worked with some delivery managers who, even before I would say anything, when there was a performance problem, they say, well, have you updated the statistics? Because far too many times updating the statistics would resolve a performance problem that was caused by a plan regression. There are other causes of poor performance, but I always remember on that particular project, we used to see that a great deal. Oracle delivers this package, DBMS Stats, that calculates and manages the statistics. And it collects object statistics on an object, a table, an index. Or you can say, give me all of the objects in a schema, or just collect stats on the whole database. And you can say, just collect stats where the statistics are stale or out of date because there's been too much change. You can also have it delete stats. You can also lock stats. This is a bad term, but it's Oracle's term. What they mean is take responsibility for the statistics away from the default schema-wide Oracle standard jobs, and you take responsibility for it yourself. And the other thing you can do with this package is you can export and import stats to and from a table and migrate them between systems and that kind of thing. Before Oracle 10, so up to about 9i, it was really common for people to write their own custom homegrown statistics collection scripts, and not just on PeopleSoft systems either. People would write these weird and wonderful scripts and they'd be totally non-standard, and invariably they'd collect statistics on everything and it would take a long time, and invariably they computed statistics on far too many tables as well, so you did far more work on a table than was strictly necessary. And Oracle started to take a grip on this from about Oracle 10 with automatic statistic sizing and with a maintenance window, a standard overnight scheduled job. So by default, the maintenance window runs weekdays. That's not right. It should be 10 till 4. It's only 6 hours at weekdays now. And it runs all weekend. And it only collects statistics on tables that are stale. And a table is stale if there is 10% change. So they track the number of inserts, updates, and deletes, and they also track truncates. And if the table's either been truncated or if the change is 10% of the number of rows currently recorded in the stats, it's stale. And you can set that 10% standard at database level, and you can override it at table level from 11G. And they also introduce statistics locking, and that means you can omit a table from statistics gathering. But you can still collect statistics on it yourself, but you have to use this fourth option to override the lock. I'll come back to that in a bit. So they've given you this package to control your statistics. It's one of lots of delivered Oracle PL SQL packages. You can't see what goes on inside. The code is obfuscated and wrapped. But you can see the results of it, and you can see the statistics as in the data dictionary tables. There's a couple of new features if you are lucky enough to be going to 19C on an engineered platform, Exadata or Supercluster. There's a couple of new features which I'm not really going to talk about much today. There's real-time stats and high-frequency stats collection. That's something new that they've delivered on Exadata. And again, it's all about delivering the right statistics at the right time to the optimizer. So what statistics should you be worried about collecting? What parameters should you actually set for this package? Well, the favorite things that you can work on are method opt, which controls which columns you collect histograms on. And histograms deal with skewed data, data that's not uniformly spread. Simple example might be a status column. Some statuses are more common than others. So it would be a good idea to have a histogram on a status column. You can specify the degree, which means the statistics are collected in parallel using parallel query. With a partitioned object, you can control whether you just collect stats on partitions or subpartitions, and whether you have incremental stats, which means higher up at table level, the table statistics on a partitioned object, they're calculated mathematically from the partition statistics. And you can also set the stale percentage. These last two can only be set as preferences, so they're declarative settings in the data dictionary, which describe how statistics are to be collected on an individual object. Things you must not specify anymore. You should never specify sample size. Since Oracle 11, to be honest, you should only use auto sample size, which is the default, because if you don't use it, you won't get the new hash-based number of distinct values calculation. And from Oracle 12, you won't get the top N and hybrid histograms. You'll only get the old-fashioned height balance histograms, which are not as effective and take longer to calculate. And there's no point setting cascade anymore, because that defaults to true. And cascade means if I'm collecting stats on a table, I'll cascade it down to the indexes, and it's true by default. So we don't need to worry about that anymore. Should we collect histograms by default? This is tricky. DBAs argue this one endlessly. By default, the Oracle behavior is it collects histograms automatically on the basis of skew and usage. So it looks at the skew of the data in a column, and it will also say, how often are you using it for a predicate? It's something that's tracked with table monitoring. So by default, it's for all column size auto. And what Oracle say is, if you've got columns where you know you don't want a histogram, then override it with method opt. Set a table preference so that when you collect stats on that table, you don't collect stats for that column. So you say for all column size auto, but for the exceptional column size 1, and size 1 means one bucket, which is just min-max value, no histogram. And you manage by exception. And you'll find Oracle presentations. There's one from Maria Colgan. She used to be the optimizer product manager, and now she's the distinguished product manager for the Oracle database. But the optimizer is still very much Maria's thing. And you'll see lots of presentations from Maria on Oracle's YouTube channel. But that's not the only view. If you talk to Jonathan Lewis, and if you're afraid with the Oracle world, you know that Jonathan is probably outside of Oracle Corp, one of the best known commentators on the database and performance and the optimizer, author of books. And again, I'm very lucky, he's based in the UK in London, and I get to go and watch him at Oracle user group meetings. And Jonathan's view is you shouldn't gather histograms unless they are frequency or top frequency histograms, and you shouldn't use size repeat in Oracle 12c onwards, because if the number of distinct values goes down, the repeat size will go down. And if it goes back up, you'll go back up to top N histograms. And then he says, on that basis, change the default to for all column size 1. But if you know you need histograms on a column, manage by exception and set a method opt for that column size, whatever it needs to be. And then if you've got some really unusual cases, often it's the monster tables in a system, write something to generate histograms. And there's a link to Jonathan's presentation on the subject. Now, I've been really lucky to watch Jonathan and Maria slug this out live at a conference session and argue it back and forth. And both views have merit, and I'm not going to adjudicate between them. But both views also say, there's no question, but you have to be responsible for managing the exceptions. And there will always be exceptions, and you will always have to reach in and adjust them. How you reach in and adjust them, I'll talk about in a couple of slides. Then we come to something that PeopleSoft has got a lot better at doing, actually, and that's collecting statistics on the temporary working storage tables in its batch processing. Now, that's mostly on the temporary records in App Engine, but COBOL does it too. And it uses regular type 0 records, not the type 7 temporary records. And it tends to truncate them, repopulate them, and then query them. Well, if you're going to truncate and repopulate a table, you should collect stats on it. The general principle is always tell the optimizer the truth. The trouble is, there are occasions where you tell it the truth and it still does the wrong thing, but you should still tell it the truth. When you populate the table, you collect stats on it. And PeopleSoft themselves have got much better at putting the update stats macro into their delivered App Engine code. And that's what invokes DBMS stats. And I think since 8.5.5, COBOL has also used the DDL model, just like App Engine. So the update stats macro comes with a low and high option, which is a throwback to the bad old days of the analyze command when it was analyze low and analyze high. So there's two DDL models. And in fact, they should both be the same, but they're not. This is what Oracle actually delivers. In update stats low, they have estimate %1. Now, in my opinion, this is just wrong. And Oracle should have done something about this in PeopleSoft, but they still haven't. They're still delivering what I say is the wrong DDL model. First of all, they're specifying a non-standard estimate %. It should always be DBMS stats auto, like it is for the high. But they deliver estimate %1, wrong. They also set method opt for all index columns size 1. Now, what does that do? It only collects column statistics on the index columns without histograms. But it doesn't collect statistics at all on the unindexed columns. So if you have a predicate on an unindexed column, it will miscost it because the statistics on that column will get older and older and older. Now, this mainly affects the temporary records in App Engine, not the regular tables. I say that the DDL model is wrong. What you should have in the DDL model is just this and nothing else. Gather table stats, owner and table name, and that's it. And false equals true in case you lock the table. Why would you lock the table? I'll explain in a minute. So anytime a PeopleSoft process collects stats, that's what it should do. It should call the DDL model and do this. By the way, don't ever code DBMS stats into your App Engine. Only use update stats because DBMS stats implies a commit. And there are times when you do not want the commit to occur. And there are times when update stats is suppressed by App Engine because of the commit. So if you're inside a tight loop, it will suppress commits and it will suppress update stats, and you'll get the message in the App Engine log. And you should not set any other parameters in this at all. If you want to control how statistics are collected on a table, I think you should do it declaratively by specifying a statistics override in the database data dictionary. And then that that preference gets picked up by DBMS stats when it collects stats on that table. And it will happen anytime anything collects stats on that table, whether it's a single table stats collection or if it's the schema-wide or database-wide stats collection that runs as a part of the maintenance job. The problem is what happens if you don't collect stats at runtime. So yesterday I ran an App Engine, process instance 1,000 say, and it truncated and populated a table used for temporary working storage. Truncate does not remove statistics. It never has. So the statistics on the table are now stale. I've got new data, but the statistics are from the previous run. I ran my process, I updated the data, and then overnight, the statistics maintenance window ran and it updated the stats. But the process is finished. It's too late. But there, you've got up-to-date stats for the data that's in it. I'm going to run the same batch again today, and I'm back to the same problem. I'm now going to run the batch with last night's statistics, and now I'm running process instance 2000, and I've got statistics that say the process instance number is in the range of 1,000 to 1,000. So you ask the optimizer, how many rows do you think have got value 2000? And it's going to say, 2000 is outside the range of values. You're going to get one row. Wrong. You're going to get all the rows in the table. So maybe that would make the optimizer do an index lookup on this table where perhaps it should do a full scan. And that kind of mistake in the mathematics leads to generating the wrong execution plan. So The only time when it is correct to collect statistics on working storage tables is in the process that populates them and not at any other time. And that includes with the maintenance window and with real-time stats. So you either collect stats on the table at runtime, or you don't have stats on it at all. And if there are no stats on it, Oracle will do a thing called optimizer dynamic sampling. By default, optimizer dynamic sampling is set to 2, which Oracle will collect stats on the fly in memory and not save them to the data dictionary if they don't exist. You can set it to level 4, which means it will also do extra maths if you've got complex multiple predicates on the table, and that's generally beneficial, but I have had trouble with NVision. So you might want to set it back to 2 for NVision while setting it at 4 at database level, something I've actually can do with a trigger. There's some code out on GitHub. So what I recommend is that you lock the statistics on all of your temporary records. So that's all of your type 7 temporary tables, and there's a selection of other normal records, type 0 records. Normally the name ends in AET or TAL, and they're only used for working storage. So you lock stats on this so that none of the maintenance window jobs collect stats, only the batch processes that are working on them collect stats if it's coded. And if it's not coded, that's all right, we'll use optimizer dynamic sampling. You should also delete the stats on these tables at the same time as you lock them so that you don't have any leftover stats from before you locked them. I think you should change the DDL model, as I have shown you before. And now, because you're locking it, you need to use the force option, because otherwise you'll get an Oracle error when you collect stats on the table. And now the force option means you override the lock. And obviously, as I've said, you never call DBMS stats yourself inside your App Engine. I'd also say, consider the GFC PS stats package. Now, this is something I wrote to assist with statistics collection, and I'll talk a bit more about that later when I talk about CBO stats. Something that's new in Oracle 12.2, it's a very nice trick they've added. It's a statistics preference called preference overrides parameter. And if you set it, every time you call DBMS stats with a parameter in the call, it will ignore that parameter. So you might say sample size 1%, but if you've set this, Oracle will say, I'm going to ignore whatever you've put in your call to DBMS stats. I'm going to go with the table preference, which will be the global preference by default would be auto sample size, unless you've overridden it with a table specific preference. This preference setting forces the use of the data dictionary declared statistics preferences, so that if someone has coded something peculiar, it will have no effect. They won't be able to do the wrong thing. And as the DBA, you have control over it. Even if you haven't got this problem, I'd still set this preference to stop this problem ever emerging. And there's a couple of blogs out there there's one of mine, there's one from Maria Colgan, that explains how this feature works. Of course, you've then got the question of what happens if someone comes along with App Designer and alters the table by recreation. They drop the table and they recreate it. You will lose all of your table statistics preferences for that table. And again, I've solved that problem with GFC PS stats, and I'll describe that in a bit. One of the nice things that Oracle does is it collects statistics history. So every time you collect statistics, the old statistics are put in a history table, which is stored in the sysorgs table space. This is usually very nice, but on PeopleSoft, it's an absolute pain because you've got some batch processes, time and labor does it in HR, and there are some GL processes that do it. They go around a loop and for populating a temp table, and every time they populate the temp table, they collect stats on it. And it's, by default, this history is retained for 31 days. I've opened up systems and I've seen dozens of tables with 10, 20, 30, 40,000 sets of statistics and histograms as well, therefore, all stored in the statistics history table. And this causes trouble because it's DBMS stats itself, the gather table stats operation, that's responsible for purging statistics history. So you collect statistics and it will also check to see if it's purged. So having 40,000 copies of the statistics is completely useless, takes up space, occupies time in processing. Despite the fact it would be nice to keep statistics history so you can track table growth, I would turn it off. Unfortunately, you can't turn it off per table. You can only turn it off globally at database level. So I would turn it off globally at database level, unfortunately. The other thing is, if you've turned it off, but you have had history in the past, reorganize the tables in the sysorgs table space to relinquish the space, because even if statistics history is turned off, DBMS stats parses those tables to see if it can find any history to delete. And if it's got a high watermark, it will scan to the high watermark, and that will take time. And we have found that by reorging those tables, you increase the performance of DBMS stats. And there's a nice blog from John Hallis describing how they, it's quite an old blog now, it's from 2009, describing how they purged the statistics and released the space. I know John and I know which PeopleSoft system he's writing about. So that experience comes from a PeopleSoft system, although it doesn't mention the word PeopleSoft. Unfortunately, you lose track of your growth rates, and that's unfortunate, but we'll have to live with it. It's better to go without the statistics history. Oracle put this in, I should say, in case, you know, I've collected stats and my plan goes to hell, so I can put the old statistics back to get the old plan until I can work out what's going on. I have never actually got myself into a situation with PeopleSoft where I've done that. It's terribly easy to throw rocks at the optimizer. If you think about it, it has to deal with any SQL statement that you could possibly conceive of, not just the ones that come out of PeopleSoft either. And to be fair to it, it does a really very good job with most of them. And people like me who deal with performance problems, we only see a tiny number of SQL statements that actually make a difference. As with many things that Oracle write, to be fair to the optimizer, it's designed to work with applications that are written the way Oracle advise you to write applications. And even though it is 16 years since Oracle bought PeopleSoft, PeopleSoft is not such an application. You know, that platform agnosticism is baked into the DNA. You know, PeopleSoft does some weird stuff. You know, it doesn't use nulls. You have 0 and space, so you have these special values. It has unique indexes instead of primary keys. Sometimes you find nullable date columns in those unique keys, which is a disaster. And there's no database enforced referential integrity, which is something that, as well as ensuring your data is referentially integral, the optimizer can extract information from that. So to be fair to the optimizer, it's surprising it does as well as it does with PeopleSoft. And there are going to be times when simply collecting stats is not enough. And so you end up saying, well, if I can't get the optimizer to do what I want by providing the right stats at the right time, I'm going to have to intervene. And that's code for saying I'm going to have to put a hint in there. And hints are not just hints, they're not suggestions, they are optimizer directives, telling the optimizer to do something or often not to do something. And they mostly force certain operations, or they can prevent or force certain transformations, and they can even set environmental settings. Opt_param is a way of doing an alter session command for a single statement. There is another paradox, the hint paradox. Why do we use hints? Well, we want things to go faster. What happens to optimize a cost when we add a hint? It usually increases, unless I'm using the hint to reset a default parameter setting. Because without the hint, the optimizer chose the cheapest plan, and if I've changed the plan with a hint, it's necessarily going to be a more expensive plan. So hang on, that meant the cost went up, but the runtime went down, which tells you something about the mathematical model that the optimizer is. There are problems with the cost model where the estimates are not correct, where it gets tripped up, where the assumptions that are coded in there are not correct. And to be honest, these are frequently at the root of performance issues. And ultimately, you beat the optimizer over the head with a hint saying, I don't care what you calculate, you just do this. So in the relatively few cases where you have to do this, you identify those cases really by looking where the estimated cost diverges from the actual cost. So if you look at an execution plan with statistics level set to all, you get estimate and actual rows. And where those estimates diverge, that's where the optimizer made the mistake. There's no question, make sure the stats are up to date. Make sure you've got the right number of histograms and make sure the histograms correctly describe the skew and they're working. And you've also exhausted whether your problem is, I need a better index to help me find the data. But you may have to introduce a hint. Now, Oracle provide various forms of plan stability through SQL baselines, SQL patches, SQL profiles if you're licensed for the tuning pack. We used to use outlines in the past, they've been deprecated and they're replaced by profiles. The catches are that baselines and patches, which you don't have to pay to license, are tied to the individual SQL statement. But of course, PeopleSoft likes to dynamically generate things. You get literal values and different literal values each execution. So that means the SQL ID changes. Okay, so you can use forced matching with a SQL profile. What do you do with, say, App Engine, where you've got, today I'm on table 1, tomorrow I'm on table 2, the day after I'm on instance 3 of a table. The statements are the same, but because they're a different table name, they're a different forced matching signature. So even forced matching can be tough to use. I've had to write sets of SQL profiles at times. I've got a financials COBOL process. I had to write a set of 1,200 profiles to tune one SQL statement. It's crazy. When you're faced with that, and the alternative is to put it in the code, frankly, it's easier to put it in the code. It does mean it's a code change and you've got to go through the whole code change, release control, testing, everything to get it out there, but sometimes that is the lesser evil. I do try and avoid hinting when I can. If you really must hint, be aware of the SQL hint macro in App Engine. I will not change COBOL source code under any circumstances. I will put hints into stored statements because they are static, but you can also use SQL profiles quite effectively on stored statements too, because they're static and they've got bind variables. A word about hinting. So hinting can be a bit challenging sometimes with App Engine. So here's an insert select statement on the left, and this is what it expands to on the right. Great. Supposing I need to put a hint in there. Well, if I want to put a hint in there, it has to be immediately after the select. JID is the first column, so I'll put a specific setting for the emplid column into the insert statement, insert select statement, emplid equals hint JEmplid. Great. And I now get select leading JEmplid in my resolved SQL, and that's a valid hint. Wonderful. But what if the insert select has a distinct keyword? I can't use this technique to get the hint in the right place. A hint after the distinct is not a hint, it's only a comment. That's not a valid hint. So PeopleSoft introduced the %SQL hint macro, and it lets me inject the leading hint after the rest of the statement has been resolved. So here, I'm going to insert a leading J hint after the first select statement if I'm on the Oracle platform. And that last bit, Oracle, is so that PeopleSoft themselves could deliver different hints to different platforms. And now I get my hint in the right place in front of my distinct keyword. So I think if you are going to hint App Engine and make code changes to do so, I'd encourage you to use SQL hint, but I'd also encourage you to be really sparing with the use of hints. It is a last resort because it's a code change to put it in, and it's a code change to take it out when the hint no longer works because the situation has changed. But this is just showing you the sort of power of the SQL hint macro. Various hints here into various SQL blocks. You can see select 1, 2, 3, and it's the first, second, third select statement. I've slipped an append hint into the insert. You can also have a disabled hint. So it's effectively just a developer comment. So there's all sorts of things you can do with SQL hint. And particularly if you're dealing with dynamically generated code, this can be very effective. I might also say that where I have had to deal with dynamically generated code, sometimes you need dynamically generated hints as well. And sometimes when collecting stats in an app engine, you frankly need more control. So let me give you an example from time and labor. I've seen effectively the same thing in finance as well. So time and labor is a rules engine, and as it goes round in a loop through batches of employees to who have the same time and labor rules applied to their time cards, it collects stats on the working storage tables, and there's 20 odd working storage tables. And every time it goes around the loop, it collects stats on all 20 of them. And what we found was that this collection of statistics was in itself a dominant performance issue. And that's even after we turned off statistics history. But we also found if we completely suppress statistics collection, that optimizer dynamic sampling doesn't always do the right thing. And that even so, we needed explicit stats on, I think it was 2 tables. But you know, the time and labor engine is a fiendishly complex thing, and no one wanted to touch the delivered code, least of all me. We'd already customized the DDL model. I introduced a custom PL SQL package. We changed the PeopleSoft DDL model to call the custom DDL package, and the DDL package effectively became a wrapper for DBMS stats. And we put logic into the package to say, do I collect stats on this table? And this became GFC PS stats. And it's time to talk about the elephant in the room. So this package, and it superseded the old wrapper package that was in the first edition of PeopleSoft for the Oracle DBA. I introduced some metadata, which is a bit like a tools table, 1 row per record. And it said, on this record, I will either collect stats, not collect stats, delete stats, or only collect stats if they are stale. I also produced a couple of triggers, a DDL trigger on table creation to automatically apply the table preferences, the table statistics preferences from the same metadata table to the table, and a DML trigger so that whenever I changed the metadata, it also applied the new table statistics preferences. And we simply changed DDL models 4 and 5 to call my package. And recently I've updated it. It also now sets whether statistics are locked, and it deletes the statistics on locking them. You'll find that on GitHub. You'll find it documented on my website. And it's an option for controlling the way stats are collected. If you want that finer grain control where you say, I'm only going to collect stats sometimes for this table, but not for that table. So I think that's really got some advantages. And the locking means locking these tables and using stats in this way means you leave the default Oracle maintenance window in place. You do the standard Oracle things and you're working with the database. This is all part of the make friends with your DBA policy by not making PeopleSoft a pain in his proverbial. The alternative delivered by Oracle is this package PSCBO STATS. Now, it's written by a friend of mine, Carlos Sierra, when he worked at the Oracle Center of Excellence. I worked with him for a few years at Encatech. He's gone back to Oracle Cloud. And frankly, it's based on his script for Siebel. And his script for Siebel is a very good solution for Siebel, but the equivalent solution on PeopleSoft, I'm not a fan of. And it dates back to Oracle 10, and he enhanced it for Oracle 11. It's documented in PeopleBooks. There's a note out on the Oracle support site. You can read about it. The concept is broadly similar to my package. It's a wrapper for DBMS stats to control how DBMS stats work. And to be fair to Carlos, he's dealt with a lot of some of my earlier criticisms with the new 11G release. But it doesn't really bring you that many advantages because Oracle doesn't certify it. They view it as a customization, and if there's a problem with it, you're on your own. So you're not really better off using it in the first place. There's no support for table statistics preferences. There's no support for extended statistics. So extended statistics are histograms on combinations of tables. So when you've got 2 or 3 correlated columns, you treat them as one when you calculate the histogram. And the concept for CBO stats is you use it instead of calling DBMS stats. So they say, turn off the default maintenance window and use the PSCBO stats as your stats job. Well, that's making your PeopleSoft database different to every Oracle database in the estate. So I'm biased because I wrote GFC stats, but I think it's a better, more PeopleSoft friendly solution than CBO stats. The Siebel version is fine for Siebel because there is no Siebel answer to this question. But for PeopleSoft, I wouldn't implement CBO stats. A couple other things, not about stats, but optimizer related. We had a thing in 12.1 introduced called cardinality feedback, which means that Oracle tracks the decisions it made in the past to help the decisions for the future. There's a new feature called adaptive optimization. And by now, even everyone on 12.1 will have the backported 12.2 patches. It's split into 2 parameters. And what Oracle did is they kept adaptive plans on, and they turned adaptive stats off because anyone in a high-pass system suffered, and PeopleSoft definitely suffered. So one of the first things people used to do in 12 was turn off adaptive optimization. If you've never turned it back on, once you get to 12.2 or 12.1 with the, I think, October 17 patch, these 2 parameters, just go with the defaults. So adaptive plans is about, mostly in PeopleSoft, it's about swapping between nested loop and hash join. It nearly always does the right thing. Adaptive stats is where the parse intensive processing is. Oracle turned this off by default. Don't turn it on in PeopleSoft. It will kill you. You might want to consider setting dynamic sampling to 4 as well. If you've been through 12.1, you might have a ton of SQL plan directives in your system. Again, they're tied to SQL ID, so they're not terribly effective. There was a bug in 12.1 where it caused performance problems. I think it's been fixed, but I'd be perfectly happy to turn plan directives off. And if you have to drop a ton of plan directives, well, you'll have to go through and drop them one by one. In terms of undocumented initialization parameters for PeopleSoft, we've set unnest subquery since Oracle 9 when Oracle changed the default, and it is still critically important that you turn unnest subquery off. That is now pretty much the only undocumented parameter you should be setting on PeopleSoft. There's lots of doc kicking around where it suggests other parameters, and now today on 12.2 and upwards, and on latest and greatest versions of tools 8.5.8 upwards, the argument's over, nothing else gets set. So it used to be they told you to turn global hash aggregation off, wouldn't do it. I turn it back on now because anything that is ordered, needs to be ordered, has an order by statement. So even Oracle recently have changed their advice on this, and it's now set true. This was about the only other parameter you used to see regularly set. I'm not going to talk about 2 new features in 19 very much because I've got a separate presentation that you can go and watch, but I'm involved with 2 19C upgrades on Exadata, and these are Exadata only features, and I like them. And if you're lucky enough to be doing 19C with Exadata, I'd say do it, go with these features. Real-time stats helps you deal with table changes due to DML before the stats can run. You have to turn it on from 1910 with this parameter. And then you've got this high frequency stats collection jobs, which collect stats. The job runs every 15 minutes for a maximum of 60 minutes and works through tables from the stale list to the least stale. And it's all about getting the stats up to date sooner. And of course, if you've turned off stats history, you don't have any concern about the amount of history. But if you're lucky enough to be doing 19C on Exadata, I'd encourage you to have a look at that. We haven't yet got it live, but we've gone through some pretty serious testing on 2 financial systems, and it seems to do the job. Okay, we've reached the end. My final comment would be, as far as possible, just do it the Oracle way. Work with the database, don't fight against it. Your DBA will thank you for it. If you want control over stats, use GFC PS stats, use table statistics preferences. That's about it, really. That's the ground rules for managing statistics. To every rule, there is an exception, and there are exceptions here or there, but these are the general principles. And I've got, wow, I meant to leave more. I entered more than 1 minute for questions, but.
Oh no, David, that's great. We did have one that came in here right at the end. Do you have a link or a recording to your Exadata 19C presentation?
Do.
How does autonomous database affect optimization with PeopleSoft now that that's both supported in the dedicated and shared infrastructure?
Autonomous database is what Pluggable was implemented for, so that you could have multiple databases on the same shared server. There are 2 forms of autonomous. There's the data warehouse version, and there is the transaction processing version, and you will put PeopleSoft on the transaction processing version. It's Exadata, be 19, whatever it is at the moment. So you'll have all of the features. It's just a database. Is it like self-driving cars? Well, self-driving cars still crash. I wouldn't want to take my hands off the steering wheel in a self-driving car. And the same is true of people. Some of the self-driving stuff you can go with. So the statistics collect, I mean, what is self-driving? It's a bunch of expert systems, isn't it? That are, what do they mean by autonomous? The expert systems can take action on their own without you having to authorize the action. That's what they really mean by autonomous. That's in the ordinary dictionary sense of the word. So your stats job is an autonomous system. It collects stats and it updates the stats in the data dictionary, and it decides whether to collect histograms or not. Some of the SQL tuning stuff is turned on. Doesn't work terribly well with PeopleSoft because of the dynamic generated code, and you never see the same SQL ID again. So real-time stats, high-frequency stats collection. Yeah, they're part of the autonomous self-driving, deliver up-to-date statistics to the database. They're good features. There's another feature called automatic indexing. And there's another presentation. Now, automatic indexing is Oracle will decide whether to create and drop indexes all by itself. No, that one doesn't play well with PeopleSoft. PeopleSoft takes strict control of the index model, and it's delivered by App Designer. And if you start creating extra indexes, if you're not careful, App Designer will come along and drop them for you. So I don't think automatic indexing is a feature that fits well with PeopleSoft, and I have to say, I don't think it's ready for prime time just yet. It will be soon, but not yet, because I've done some tests on Swingbench, and I didn't really get back the kind of stuff that I expected. You know, it didn't put back all the indexes that got dropped. So, you know, some of these features, they're not going to fit well with PeopleSoft. Again, these features are designed to work with an application that is written the way Oracle have been telling you to write applications for 25 years. And PeopleSoft is not such an application, because in the beginning, PeopleSoft was developed on SQL Server and stress tested on DB2 before being mostly released to Oracle. What could possibly go wrong? But that DNA is still baked into PeopleSoft. That platform agnosticism is still baked into the application. And some of this, you know, weird value stuff, lack of referential integrity, it's just not there, and it's not going to be there. I mean, it's there in, say, eBusiness Suite, And maybe eBusiness Suite is the kind of application that, well, they did used to engineer the database for eBusiness Suite and vice versa. So I don't think some of this stuff is going to play well with PeopleSoft. It just isn't. And PeopleSoft is not going to change. So yes, you will be able to run PeopleSoft very successfully on Autonomous, but you will not be able to let go of the steering wheel.
Sure.
Is my personal opinion.
Well, thanks for that.
All
right. We should probably cut to the break here, David. We could let you talk for another hour.